Yes, ma'am. I closed the door. Is it okay now?
Yeah, it's okay. It's okay.
Yes, ma'am.
Okay, now see. First question, we have done it correctly because it was very simple, right? So IUPAC nomenclature, basically it's a system which provides the standardized way to name all the organic compounds, right? And each compound has a unique name according to the IUPAC, right? So you know what is the full form of IUPAC?
International Union of Pure and Applied Chemistry.
Yeah, very good. So when you write the IUPAC name of any compound, so first step is always to identify the parent chain. Parent chain. What is the parent chain? So parent chain हमेशा क्या होता है? It is the longest carbon chain or the ring is the parent chain. Okay, so see in this question, let's find out the parent chain. So if you start, and parent chain should also consist of the, you can see here, this is the functional group, right? So you have
Yes.
to name this functional group the least number देना आपको. You have to least number this functional group. So you can start from naming the carbon from here. One, right? This is second carbon, this is third carbon, and this is fourth carbon. Similarly, you can do like this. One, right? One, two, three, four. In both the ways you can do, right? Because both the ways the parent chain is for of the four carbon chain. The parent chain is four carbon chain. So one, two, three, four, right? So now this is your parent chain. This is your parent chain,
Then,
right? So always first identify the parent chain, means the longest chain, right? So this is the longest chain. Now let's see. So you can see there are two substituent over here. One substituent, right? So this is the one substituent, right? One substituent. For substituent are basically the groups which is attached to the parent chain, right? The groups which is attached to the parent chain. So you can see this is a group which is attached to the parent chain. This is a substituent. This can behave as a substituent. Now, how many carbon are there in this substituent? One carbon and two carbon, right? So two carbon alkyl group is known as ethyl, right? Because substituent में क्या होगा? Alkyl group is present, methyl group, chloro group, anything. So you can see one or two carbon. Two carbon alkyl group means ethyl group is there. And what is the position of this ethyl group? Position is basically known as locant. Locant means location. You are just telling the location of the substituent, where the substituent are attached to the carbon. So you can see this is a parent chain, first and second. So on the second carbon, the ethyl group is attached, right? So on the second carbon, the ethyl group is attached. So how we can write? So just write down the name, say 2-ethyl. Now you will write down the root word. What is the root word? So root word we basically used for the parent chain. Parent chain, right? And parent chain are 1, 2, 3, 4. Four carbon chain. So for four, what we use? Yes,
Butte.
Aneesa? Yeah, very
Butte.
good. So we use
Yes.
bute, right? So 2-ethyl butane, because it's a alkane, single bonded. Carbon is
Yes.
attached to each other with a single bond. So we will use ane, alkane. So butane. And on which position the functional group is attached? On to which carbon? Obviously the first carbon, right? So we will use 1-ol. Okay, so that's the IUPAC name of this. 2-ethyl butane 1-ol. Clear?
Yes, ma'am.
Similarly for the third one. So you can see over here, this, what is this? First tell me. See, this is your benzene, right? You
Yes,
know,
ma'am.
this is your benzene. And when OH is attached directly to the benzene, so what it called as?
Phenol.
Yeah, it's phenol, right? So phenol is your parent chain, right? Parent is your phenol. Now, if parent is your phenol, so obviously phenol को हम क्या करेंगे? Lowest number देंगे. So it will have 1, it's 2, 3, and 4, 5, 6. Right. So that's how we can assign the number to all the carbon. Right. The OH group will get the lowest number, right?
Yes,
Second,
ma'am.
third, and fourth. Now you can see there are two substituents, bromine, and this is NH2 is your amine group. right? NH2 is your amine group, and just we use amino bromo, just like that. O हम लगाते हैं. Okay, so just bromo and amino, and we just write down the IUPAC nomenclature according to the alphabetical order. Right now, see, this is amino group, this is amino group, and this is bromo group. Okay, so obviously A comes first, then B, right? A पहले आता है, so I will write what is the amino position. So it's 4. 4 amino, right?
Yes,
Now
ma'am.
2 on the second position, bromine group is there. So 2 bromo, 2 bromo phenol. Now is it clear?
Yes, ma'am.
Yeah, you can write now. I will give you some more examples. You will go it by yourself. Then Aneesa?
I'm doing the third one. Done, ma'am.
Yeah, I'm giving you some more questions over here. CH3. Okay, I have given you the basic one. Just write on the name of these.
Okay, ma'am.
Yeah, done the first one, Aneesa.
Yes, ma'am.
Okay, tell me the name.
3-ethyl 4-methyl hexane.
Just a minute. Three
Sorry.
ethyl,
3-ethyl 5-methyl hexane. Yeah.
3-ethyl 5-methyl,
Yes, ma'am.
3-ethyl and 5-methyl
Yes, ma'am. Hexane.
hexane. Okay, now let's check it. Now let's check it. What is the parent chain? It's the longest chain. So 1, 2, 3, 4, 5, 6. Right? So again, 1, 2, 3. Yeah, when you start from here, it's also 1, 2, 3, 4, 5, 6. Yeah, so it's same. So you can take, right. Now, let's see from where we should start the numbering so that the substituent will get the smallest number, right? If we start numbering from the right side, so it will have 1, 2, 3, 4, 5, and 6, right? So the
Yes, ma'am.
substituent means from here 3-ethyl and 5-methyl means on the just a second on the third position and 5 position, right? 3p ethylene and here the methyl group. Now when you start from the see from this side, so it will have 1, 1, 2, 3, 4, 5, 6 means it will get 2 and 4. So you have to check which one is the lowest. You have to assign the lowest number to the substituent. So you should start, this is wrong, you should start from the left side so that you can see when you compare this. So this is 2 and 4. On the second position the methyl group is attached. On the this is a methyl substitute location, and on the fourth position there is a ethyl group, right? So when you start from the left it is more preferred numbering, right? So you should start from the left, not from the right. Okay.
Yes, ma'am.
Now you can write down the correct name. So that's incorrect. And right. Yeah. Now what will be the name? So it's ethyl comes first, then methyl E, right? So it's 4-ethyl. Yeah. 2-methyl hexane. Yeah. So that's the correct name. Similarly, in this case, let's see 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7. Okay. So obviously this is the longest chain. 1, 2, 3, 4, 5, 6, 7. Obviously from here, from the right side, the it will get the same number 3, 3, and 4. You can see the methyl on the third position, 2-methyl group is attached. So you can't write it as a ethyl, right? Because here the ethyl group is not attached to methyl group is attached. One on the upper side and one on the lower side, right? So
Yes, ma'am.
how we will write down the name? So it's 4 on the fourth position. There is ethyl group, right? So
Yes, ma'am.
4-ethyl, and it's 3, comma, right? On the third position, there are 2-methyl. So we will write the position for both the methyl group. So 3, comma 3, and there are 2-methyl groups. So we will use di. We will use di for 2-methyl. So dimethyl. And what is the parent root word? So it's 7, right? So for 7, we use hep word, heptane. That's the correct name. 4-ethyl 3, 3 dimethyl heptane. Got it?
Yes, ma'am.
Okay, the next one, it's very easy. Just try to name this. So obviously you will start the numbering from the this side. 1, 2, 3, 4, and 5. Okay, so it will be 3-methyl and 2 on the second position there is a ol. You can write 2-pentanol or pentane 2-ol. Both has correct, right? So you can also write 3-methyl 2-pentanol, or you can write 3-methyl 3-methyl pentane, pentane 2-ol. Both are correct. Both are correct. Got my point?
Yes, ma'am.
So have you written this?
Yes, ma'am.
Okay. Okay, now let's discuss the next one. Yeah. So which is determination of oxidation state of underlying section. Right. Basically, oxidation state. We have to calculate the oxidation state. So before doing the question, let's discuss what do I mean by oxidation state. Okay, so I'm writing it over here. Basically, the oxidation state or oxidation number is a charge. Right. Write down the oxidation state or oxidation number. Right. So the charge which an atom, which an atom of element has has its ion or appears to have appears to have in its combined state, in its combined state. Basically, what does chemic oxidation state mean? So oxidation state is basically the charge on which an atom of element has its on its ion. When the atom or when the element breaks into ion, right? So whatever the charge is on its, suppose if it is an anion, right? Suppose it has a minus charge. So that's the oxidation state of that ion, right? And if it appears in the combined state, suppose O2 is there. If it is combined with its own element, so its oxidation state is always zero. As in case of O2, S8, N2, so all molecule have the oxidation state zero. Just remember that. Right? So what is oxidation state? The charge which an atom of element has on its ion or appears to have in its combined state. Okay,
Yes, ma'am.
write on this.
Yes, ma'am. Done.
Okay. See, I'm just taking the case number 1. So these are for ions. For ions. Right. So for ions, oxidation state or oxidation number is basically the charge on the ion. The charge on the ion. Ion पे जो भी charge होगा, that's the oxidation state or oxidation number of that. For example, if the ion is Na plus, right? So I am writing the oxidation state here. So what will be the oxidation state? So its oxidation state will be +1. It will be +1, right? Now, if it is Cl minus, if it is Mg2 plus, if it is aluminium 3 plus, if it is H plus, H minus, F minus, O2 minus, and 3 minus. So if the ion is given, right? Ions are given. So for ions, the oxidation state or oxidation number is the charge on that ion. If it is positive charge, whatever the positive charge is there, so that's the oxidation state. Whatever the negative charge is there, that's the oxidation state. Suppose for chlorine, Cl minus, what will be the oxidation state, Aneesa?
-1.
Very good. For Mg2 plus,
+2.
yes. And for aluminium 3 plus,
+3.
yeah. Plus,
+1.
yeah. -1. Again,
-1.
-1. Yeah, minus
-2.
minus
-3.
3. Yeah, very good. Okay, so just remember
Yes.
that. Now, write on the case 2. Case 2. After this, you will be able to solve the question. You will solve the question by yourself. Okay. So case
Okay,
number
ma'am.
2, write down. If for combined state. This is for combined state. Okay. So here first is when the atom combines with its own atom. When combined with its own atom. Just as I gave you the examples like O2, N2, S8, right? So combined with its own atom, just like your H2, O2, N2, P4. You can see H2 means hydrogen is combined with hydrogen with itself, with its own atom. Oxygen is combined with its own atom, that is oxygen. Nitrogen is combined with its own atom, which is nitrogen. Okay, four phosphorus are there, means all the phosphorus are combined with each other, right? Similarly,
Yes, ma'am.
S8, S8. Okay, and yeah, for the halogen also. For halogen, not halogen, for all the noble gases like helium, right? Helium and carbon. Okay, if carbon alone is there, so for all these oxidation, just remember that the oxidation state is 0, right? Oxidation state is 0. Just remember that. Second, so if it is with combined with different atom, different atom. If the atom is combined with a different atom, so the atom with higher electronegativity, you have to compare the electronegativity. If with higher electronegativity gets negative oxidation number, the higher electronegativity gets negative oxidation state per bond, per bond. Suppose if HCl is there, if hydrogen is combined with chlorine, and we know that chlorine is chlorine is more electronegative than hydrogen, right? So what will happen? This chlorine will have -1, right? And this will have +1 oxidation state, right? Suppose if it is
Yes.
ammonia, NH3, right? NH3. So that's the structure of NH3, means 3 hydrogen is attached to the nitrogen, right? Now we have to see each for each and every bond, means the if the suppose in nitrogen and first bond, see the first bond, just a second. So, yeah, see this bond, see this bond. We will talk about per bond, each bond. Okay, so see this bond, N or H bond, N H bond. So we know that nitrogen is more electronegative than hydrogen. Obviously, on nitrogen, nitrogen will acquire -1 charge and hydrogen will acquire +1 charge. Right? Means oxidation state of nitrogen in this bond, per bond. I'm just talking about the per bond, not for the whole ammonia. For whole ammonia, see. Now let's talk about this bond. Let's show this by different pen. Yeah. So now we are talking about this. Now this NH bond. Again, say in this NH bond, say nitrogen will acquire negative charge and the hydrogen will acquire +1 charge. Now similarly, in this bond, in this bond, see this NH bond. Again, the nitrogen is more electronegative than hydrogen, so obviously this will acquire -1 charge and this will acquire +1 charge. Now all the hydrogen have +1 charge, means plus oxidation state of hydrogen is fixed, which is +1. But the nitrogen here, what will be the oxidation state? The sum of these three, -1, right? -1 plus -1 plus -1, which gives you -3. right? So what is the oxidation state of nitrogen? So again is -3. Clear?
Yes, ma'am.
Means atom with high electronegativity will get negative oxidation state per bond, for each bond. Okay. So again, okay, let's take one more example. Yeah, here I'm writing, suppose if it is N nitrogen and here fluorine is there and here the hydrogen bond is there and here the hydrogen. Now, we have to check for each and every bond. See this bond, NF bond, nitrogen fluorine bond. So between these two, which one is more electronegative, nitrogen or fluorine? Yeah, fluorine. Halogens are more electronegative, right? Halogens are more electronegative. So obviously this fluorine will get -1 charge and this will get +1 charge. Now we will talk about this bond. Let's see this bond. Say this bond. Now what will happen? Obviously between these two, between nitrogen and hydrogen, nitrogen will have the electronegative, more electronegative than hydrogen. So obviously this nitrogen will acquire -1 charge and hydrogen will acquire +1 charge, right? Similarly, when we talk about this bond, right? So this bond, see, obviously the between these two, nitrogen will acquire negative charge because it is more electronegative than hydrogen, and hydrogen will acquire +1 charge. Now let's see. The overall charge on nitrogen will be this +1 and -1 cancel out, and the overall charge will be -1. Means the oxidation state of nitrogen is -1, right? And what is the oxidation state of fluorine? So it's -1, right? And what are
Yes.
these oxidation state of this hydrogen? +1, +1. So clear? So we will talk about the per bond. Means high electronegativity, high electronegative atom will get a negative charge per bond. Right? Clear? Is it
Yes.
clear?
Yes, ma'am.
Okay, now write down the rules. Have you written this?
Yes, ma'am, I wrote.
Every point? Okay, because I'm going to erase it. Now write down the rules for the calculation of oxidation state. Rules. Rules of for calculation of oxidation state. Okay, write on the first rule. So is always, hydrogen will have always +1 oxidation state. Hydrogen is always +1 oxidation state when, except, there is an exception, except when, attached with metal, attached with metal. If hydrogen is attached to the metal, then obviously the metal will have positive charge and the hydrogen will have negative charge. So just remember, hydrogen, if in any bond, the hydrogen will always have +1 oxidation state, except when the hydrogen is attached with the metal. Right? If the hydrogen is attached with the metal, then metal will got the positive charge and the hydrogen will get the negative charge. Right? So in this case, then when it is attached to hydrogen, when it is hydrogen is attached to the metal, then the hydrogen will have, it is -1 oxidation state. Just remember this point. Now the second point, fluorine is always negative. Fluorine is always -1. Fluorine का हमेशा आपको क्या लेना है? -1 oxidation state.
Yes, ma'am.
Yeah. And oxygen is usually -1 oxidation state. -2 oxidation state, sorry. Right. Now, fourth point, all the halogens are, means your fluorine, chlorine, bromine, iodine, halogens, all the halogens are generally generally -1 oxidation state. Yeah, group 1 means alkali metals. Alkali metals, your lithium, right? Your lithium, sodium, potassium, and so on. So group 1 elements are basically +1. And group 2, which are alkaline earth metals, they have +2. Okay, so these points are very, very important. Just keep in mind.
Yes, ma'am.
Well, you have written?
Yes, ma'am. Can you show the last point?
Yeah, yeah.
The Yes, ma'am. Thank you.
Now I will give you some question. Let's check. Let's check whether you understand or not. Okay, write on the question. You have to determine the oxidation state. You have to tell me the oxidation state. First one, Al2O3. You have to tell me the oxidation state of the underlying species. Second one, MnO4 minus. Third one, A2. Okay, don't just do the two questions. Okay, do these questions. And yeah, just always I will tell you one example. I will show you. Then you will do the next one. See, suppose we have to determine the oxidation state of the underlying species. So underlying species का हम oxidation state, just suppose let's take X. Okay, so let oxidation state of unknown species which we have to calculate be X. Right. So you can see there are two atoms of aluminium. So it will be 2X plus. Now there are three atoms of oxygen. So 3 into, and what is the oxidation state of oxygen? Yes, Aneesa?
Minus
Minus
2.
2. Yeah, so minus 2. And basically which is equals to the total charge. Now you can see this is a neutral atom. There is no charge, right? If suppose if there is a negative charge -1 over here, so you will put is equals to -1. But there is no charge over here. Right? This is a neutral atom, neutral molecule you can say. So you will put equals to 0. Okay, now
0.
just solve it. It's very simple. 2x now plus 3 into -2, 6 plus minus minus. So you will put minus over here. Minus 6 equals to 0. So 2x equals to 6. So x equals to +3. Right. So what is oxidation state of aluminium? So +3. Similarly, just calculate it for manganese. Just let's manganese be x plus. Now, how many atoms are for oxygen? Oxygen 4. And what is the oxidation state of oxygen? So -2
Minus.
is equals to now what is the overall charge here? Minus. It means -1 is equals to -1. So x plus minus 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 8 to 4 to the 8 is equals to -1. X is equals to -1 plus 8. So x is equals to minus plus minus. So it will give you +7. Right. So that's your answer. That's very easy. Clear?
Yes, ma'am.
Now you can do this question. Clear? Now do this question. CR207. And yeah, see, this was a similar question. अभी जो मैंने दिया, this is the similar question. MnO4 -1. Right. So what will be the oxidation state? +7. Do the first one. Do the first
Yes,
one
ma'am.
and tell me the answer.
Ma'am, what would be the overall charge?
Overall charge is 2 minus, means -2. Just
Okay,
put
ma'am.
is equals to -2. Whatever the overall charge, just put it is equals to -2.
Okay.
Done, Aneesa?
Yes, I'm done.
Yeah, tell me the oxidation state.
Plus 6. X is equal to plus 6.
Very good. And yeah, sometimes the question can also come like this. K2Cr2O7, right? K2Cr2O7, and they just give you the underlying species, chromium. So in this case also, this is a similar question, right? So this is a basically ionic type of molecule, right? So obviously K plus, it will dissociate to form 2K plus and Cr2O7 2 minus, right? So that's the species. See, it is Cr2O7 2 minus, right? So that's how you can just calculate the oxidation state.
Okay.
Okay, see the next question. This is very important. This is a question from the first unit stoichiometry topic of class 11, right? So see what is given over here, 25 kg of nitrogen N2 when it when it reacts with 10 kg of hydrogen, right? So they produce ammonia, NH3. Question is calculate the amount of ammonia which is formed, and the second is calculate the amount of unreacted species. But see, unreacted species, don't be confused in that. There are two type of the species, limiting species or limiting reagent, or unreacted species means excess reagent, right? So when the two reagents are given, so one reagent is that which is responsible for the completion of the reaction, which is in limit amount. जिसका amount जो होता है that is in limit amount and which is responsible for the reaction to stop, right? That is that limiting reagent. Basically, there are two types of reagent in any chemical reaction: limiting reagent and the excess reagent. Excess reagent. Limiting reagent is that which are limited in amount and that is responsible. That reagent is that reactant. You can say that reactant or reagent is responsible to stop the reaction because they are limited in amount. Okay, if something is limited in amount, so they can stop the reaction. आगे proceed ही नहीं होगा reaction because they are in limit amount. वो खत्म हो गया, वो पूरी तरह से consume हो जाता है reaction. That's a limiting reagent which gets consumed, fully consumed in the reaction, and that is responsible to stop the reaction. That is a limiting reagent. And the excess reagent is that which is present in excess amount. If one reagent is limiting, one reagent is present in a small amount, so obviously the second one will be in excess amount. So that's the excess reagent. Okay, so see how to proceed this type of question. Okay, I'm erasing this first. Yeah, see Aneesa. So according to question number 3. So what is given? First, always write down the balanced chemical equation. For a stoichiometric type of question, always write down the balanced chemical reaction because balanced chemical reaction is the uh, basic thing, right? Means that's the skeleton of the question. अगर आप balanced chemical reaction नहीं लिखते हो, so you can't do the question. That is very important to write on the balanced chemical because everything is related to anyhow, whether it's directly or indirectly to the balanced chemical equation. Okay, so here what they give, nitrogen N2, it reacts with hydrogen, and when they just combine together, when the reaction occurs, so they form ammonia gas, NH3. Now let's balance the equation. Okay, so three hydrogen. Okay, now okay, two nitrogen. Okay, now see, check it. Is it balanced? Yeah, it's balanced. Now it's balanced. Now, according to balanced chemical equation, can we say that one one mole of ammonia or one molecule of ammonia, it reacts with 3 mole of hydrogen to give 2 moles of ammonia. 1 mole of nitrogen, it reacts with 3 mole of hydrogen to give or to produce 2 moles of ammonia, right? So means if you can calculate it in uh, you can weight, you can calculate the weight also. See, so one nitrogen का weight क्या आता? What is the atomic mass of nitrogen, Aneesa? Atomic mass of nitrogen? 14. Atomic number is atomic number is 7, right? Its atomic mass is 14. Right, so you can see there are 2 atoms of nitrogen. So means 14 into 2, 14 into 2, that is your 28 gram. 28 gram of nitrogen. It's reacting with. Now, what is atomic mass of hydrogen? Atomic mass of hydrogen is 1, right? So you can see there are 3 to the 6. 6 hydrogens means 6 gram. 6 grams of hydrogens are there because the stoichiometry यहाँ पे coefficient is 3, right? And 2 atoms are there, so 3 into 6. Basically, 6 atoms of hydrogen is there. So for one hydrogen, the atomic mass is 1 gram, right? So for 6 hydrogen, the atomic mass is 6 gram. Now just calculate the atomic mass of the ammonia. For nitrogen, 14, 14, and for 3, 14 plus 3, 14 plus 3, 17, right? And 17, there are 2 moles, right? यहाँ पे क्या लगा हुआ है? Coefficient is 2. So 17 into 2, 34, right?
Yes, ma'am.
Got the point? How 34 comes?
Yes, ma'am.
Yeah. Now see, from equation, can we say that 1 mole of N2, 1 mole of N2 means 28 gram of nitrogen. It reacts with 3 mole of H2. 3 mole of H2 means 6 gram of H2 to give or to produce how many moles? 2 mole of ammonia. 2 mole of ammonia by weight means 34. Yeah, so it's nothing. I have just written it from the equation, from the balanced chemical equation. 1 mole of nitrogen N2 means 28 gram. Weight क्या होगा? 28 gram. When it reacts with 3 mole of H2 to give 2 mole of ammonia. Now, because what is given over here, basically the amount of hydrogen and amount of you can see amount of nitrogen and amount of hydrogen is given, right? 25 kg and 10 kg. So we will compare these two first. So one thing which is given, we have to compare between these two. Okay. So now see, can we say that 28 gram of nitrogen, it's combining with 6 gram of H2 according to balanced chemical equation. See, 28 gram of nitrogen, it's combining with 6 gram of H2. I've written over here, right? Now, from unitary method, you can calculate for 1 gram. 1 gram of nitrogen will give how many grams of H2? Yeah, just calculate it. 28 gram of nitrogen is giving 6 gram of hydrogen. So 1 gram of nitrogen will give 6 upon 28, right? 6 upon
Yes,
28
ma'am.
gram of hydrogen. Now let it be. Now what is given in the question? How many grams are given? Basically, see, in the question hydrogen का weight दे रखा है. It's I think 25. No, hydrogen is 10 kg, right? And nitrogen is basically 25 kg, right? Is it right? Yeah. Basically, 25 kg means 25,000 grams, right? Because we are talking about the grams. So we can write 25,000 grams of nitrogen. It will give 6 upon 28 into 25,000 gram of H2. Is it clear? This point, this line is clear, Aneesa?
Yes, ma'am.
1 gram of nitrogen is giving this much. So 25,000 gram will this multiplied by this 25,000, right? Now you can just calculate this 6 upon 28. 2 3 are 6, 2 1 are 2, 2 4 are 8. Now When you multiply this, 5,000 into 3 means 25,000 upon 14. So it will give you 5357.14 gram of H2, right? Is it clear, this calculation?
Yes, ma'am.
5357. Now see, here's the point. Now, according to calculation, what we have in the question, so 25,000 gram means 25 kg. According to question, 25 kg. अगर आप नहीं भी लिखते हो तो it's okay, because it's known that 25 kg is equals to 25,000 gram, because we have converted this. 25,000 gram of nitrogen is giving 5357.14 gram of hydrogen. Only this amount means 25 kg of nitrogen is giving 50, means you can say 5 k 5.3 kg. Yeah, when you convert this, you will get 5.3 kg, right? And when you convert this 25 kg, this is 25 kg means 25,000 gram, right? So see here, this is statement, because this is a calculation part. हमने ये calculate किया from the balanced chemical equation, right? This relation came from the balanced chemical equation. Means 25,000 grams के लिए हमें कितना need है hydrogen की? So only 5.3 kg. But in the question, the amount of hydrogen is given 10 kg, right?
Yes,
Understand or
ma'am.
not? समझ आ रहा है अनीसा?
हाँ.
Any doubt? Yeah. So see, 25 kg of, so you can see question. 25 kg of nitrogen, it's reacting with 10 kg of hydrogen to form ammonia. But it is very much amount, amount is very much, right? Because इतना need ही नहीं है हमें. According to balanced chemical equation, we just only need 5.3 kg. Means we can say that hydrogen is in excess amount. Can we say that? हाइड्रोजन
Yes.
अमाउंट क्या है हाइड्रोजन इज एक्सेस अमाउंट बिकॉज वी डोंट नीड हाइड्रोजन एज अ 10 kg बिकॉज हमारा काम चल जा रहा है 5.3 kg में राइट 25 kg नाइट्रोजन के लिए हमें सिर्फ 5.3 kg हाइड्रोजन चाहिए टू फॉर्म अमोनिया राइट सो in the question 10 kg is given so we can say that hydrogen is the excess reagent. Hydrogen is the excess reagent. यहाँ तक clear? Any
हाँ.
doubt? Yeah.
No,
So
ma'am.
according to question, 25,000 of gram of nitrogen is equals to, well, according to question, this is according to question and this is from balanced chemical equation. From calculation or balanced chemical equation. Means from a stoichiometry we got this, but according to question, 10,000 gram of hydrogen is required. So when you compare these two, you can say that H2 hydrogen is excess reagent. Excess reagent. And if hydrogen one, I just told you, if one reagent is in excess amounts, obviously the second one will be will be the limiting reagent, right? Will सी बिकॉज हाइड्रोजन का अमाउंट अभी भी है हमारे पास बट नाइट्रोजन अमाउंट इज फुल्ली कंज्यूम्ड नाइट्रोजन means 25 kg nitrogen is fully consumed in the reaction to produce ammonia. And I told you what is limiting reagent. So limiting reagent is that especially that reactant which is fully consumed in the reaction to produce a product, right? And which is a limit in amount. So obviously, if hydrogen is excess reagent, so obviously it means that nitrogen is limiting reagent. Just remember that. Clear?
Yes, ma'am.
Okay. So see, always remember, I just told you, limiting reagent is responsible for the chemical reaction and for the formation of the product, right? So when the first, always try to I'll always try to find down which one is the limiting reagent. If limiting reagent आपको पता चल जाता है which one is the limiting reagent, then compare that limiting reagent to the product, right? Now we have a limiting reagent. We know that nitrogen is the limiting reagent. Now अब हमें hydrogen से कोई मतलब नहीं है. Just keep aside. Hydrogen को side रखो, right? Now nitrogen is a limiting reagent, so try to make the relationship between the nitrogen and the ammonia. Okay, now write down. Now 28 gram of, according to, again, that's why I told you in stoichiometry balanced chemical reaction is very important. Okay, because everything is related to the balanced chemical equation. So now 28 gram of N2 produces how much amount of ammonia? 34 gram of ammonia. 34 gram of ammonia. Okay, so what will be the mass? So you can say that mass of ammonia produced by 25,000 gram of N2 will be, right, is equals to, means 25,000 gram of nitrogen से कितना mass आपका निकलेगा ammonia का? So it will be 34 divided by 28. Similar unitary method, or simple way, you can write on one more step here. You can just calculate it for 1 gram, right? So 1 gram will give you 34 upon 28. So 25,000 gram will give you 34 upon 28 into 25,000. Okay, so I have skipped one step because I know you know very well this is step here. Just a second. Yeah. So mass of ammonia produced by 25,000 gram of hydrogen will be 34, right? This 34 divided by 28 into 25,000, right? 25,000 gram of, this is all about the ammonia. Now just calculate this. See. Now, when you calculate this, the final answer will come as 30,357.14 gram of ammonia. 30,357.14 gram of ammonia. Now see, in the question, the amount of all the reactant is given in kg. So just try to write down the final answer in kg, right? So because in the question, amount of nitrogen and amount of hydrogen is given in kilogram. So that's why I'm converting this final answer, the production means the formation, the amount of ammonia which is formed in this reaction in kg, right? So it means that how many kg? So obviously just divided by 1000. So you will get 30 point, round off करके क्या आ जाएगा? 30.36. Yeah, 30.36 kg of ammonia is formed. So this is the answer first. A का answer है ये. Right? I think there were two questions were there, right? So first question, calculate the amount of ammonia formed. So it is 30.36 kg. Right now, see the second question. Calculate the amount of unreacted species. So how you will calculate the amount of unreacted species? We know that unreacted species is hydrogen, which is in excess amount. Now, 10,000 gram of hydrogen was given, and means 10 kg, you can say 10 kg of hydrogen was given, and we have the required amount of hydrogen is only 5.3 kg. So what will be the amount of unreacted species? So 10 minus 5.3 kg, right? 10 minus 5.3 kg. Yeah, so you can write the amount of unreacted species will be 10 minus 5.3 kg. Right, so it will give you 4.6 kg something. But first you can just try to find it in the grams also, or after that you can convert it. Right, तो यहाँ पे आप निकाल सकते हो. See here, amount of, I'm writing here, this B part, amount of unreacted species. So what is the unreacted species of? obviously H2 means the excess reagent. So what was given? The given amount was 10,000 minus your 5357.14. Right? It's in gram. Now 10,000 minus 5357 point this. So it will 4642.86 gram. Just convert it into the kg. So it will give you 4.6 kg. Right? So that's very simple. 4.6 kg. Clear, Aneesa?
Yes, ma'am.
Have you written?
Yes, ma'am. Done.
Okay. Okay, one more question is there. Let's this is the last one. Hmm. Because you have done the question number 5 correctly, you know how to find out the hybridization state. Now see the fourth question. Solution of glucose in water is labeled as 18%. 18% W by weight, right? 18% weight by weight. So, and the density is given. So calculate the mole fraction of glucose and glucose kappa molecular weight is given. Now see how to solve this question. So it's very easy again. Is 18% W by mass. W by W means mass, right? So 18% glucose, write down along with me,
Yes, ma'am.
by mass is given. Right? So just assume a total solution mass of 100 gram. Just assume it. Suppose we have a solution of 100 gram, right? Now, what will be the mass? So if the solution, so we know that if the solution mass is 100 gram, means solution contains solute plus solvent. Solute plus solvent, right? And glucose क्या है यहाँ पे? Glucose is solute, right? So you can say that if 18% glucose by mass is given, and if we have a total solution of 100 gram, so what will be the mass of glucose? Mass of glucose will be obviously 18% of 100 gram, yeah, because 18% mass is given, so 18% of 100 gram we have a solution. So obviously 18 by 100 into 100, so this will cancel out and you will get 18 gram. So what is the mass of glucose? Means solute, so 18 gram is the mass of glucose. Now, this is a glucose solute particles. Now, what is the solvent over here? Obviously the water. So just calculate the mass of water also. Now we have a solution of 100 gram, right? 100 gram solution है और हम उसमें से हमारे पास solute means glucose is 18 gram. So obviously the rest one will give you the mass of water. So 100 minus 18, it will be the mass of water, 82 gram. Right? 100 is the solution, mass of solution minus the mass of solute. So it will give you the mass of solvent, 82 gram. Now, number of moles. Let's find out the number of moles of glucose. I'm writing G for glucose, Ng, right? So, and the number of moles. What is the formula of number of moles, Aneesa? What is the formula of number of moles? Let's see, it's given mass upon molar mass, right? Write down is given mass upon molar mass. So we have to calculate the number of moles of glucose, right? So what is the given mass of glucose here? 18, right? And what is the molecular mass of glucose? So see here in the question, it is given molecular mass, right? The molecular mass is given over here. But if the molecular mass is not given in the question, so you can calculate it using the formula. We know the formula of glucose is C6H12O6, right? We know the formula here. Now, easily you can find the molecular mass. Now see, there are 6 carbons. 6 carbon, and what is the atomic mass of carbon? So it's 12. 6 multiplied by 12 plus how many hydrogens are there? 12. What is the atomic mass of hydrogen? So 1. How many oxygens are there? 6 into. And what is the atomic mass of oxygen? Yes, Aneesa.
Yes, ma'am.
What is the atomic mass of oxygen?
16.
Yeah, it's 16. Now, when you calculate this, when you add this, you will get 180 gram per mole. Okay, so that's what the molecular mass of glucose is. Now, substitute this in the formula. 18 divided by 180. Okay, so 1 upon 10. So it will give you 0.1 mole. Now, similarly, you can find the number of moles of water also. Okay, so tell me what is the given mass of water over here? Say 82, right? Then see
Yes,
over
ma'am.
here, say 82. And what is the molecular mass of water? You will tell me. H2O. Just find it. Yeah, it's very simple.
18
Yeah,
total.
very good. Yeah, very good. So 82 divided by 18. Right, just try to solve this. 941. So when you divide this, you will get approximate value 4.556 mole. Okay, so we have calculated the number of moles of glucose as well as water. Now we have a formula to calculate the mole fraction. And you should remember this formula. This is very important. The mole fraction of any molecule can be calculated using this formula. Suppose we have to calculate the mole fraction of glucose. The mole fraction is equals to the number of moles of that we जिसका हम calculate कर रहे हैं तो we just take the number of moles of that in the numerator part and the total number of moles means the sum of moles of each and every particle. There are two particles, दो components हैं, so the sum of the moles number of moles of all the components means यहाँ पे कितने components है glucose plus water, so the number of moles of glucose plus number of moles of water. Right now, it's very simple now. Just substitute the value because we have calculated the number of moles of glucose as well as water. Now substitute the value. So it's 0.1, 0.1 plus 4.556. 0.1 upon 4.656. So basically, when you divide this, you will get 0.02148. Okay, and in exams, just write down the only 0.02. Okay, after decimal, just only two digits, not more than that.
Okay.
So that's your final answer. That's your final answer. That's how you can calculate a mole fraction. Any doubt in this, Aneesa?
No, ma'am. Ma'am, can you please tell me what's XG again?
The X, what X here?
Yes, ma'am.
Yeah, so this is a mole fraction. Mole fraction. Right, mole fraction is basically given by X and it is basically suppose we have a binary solution. Binary solution means binary component, because binary solution is that in which two components are there. Bi means two, right? So if there are two components, so suppose this is a binary one. Now suppose actually this is a binary one because glucose and water is there. Binary solution है, so how we can calculate the mole fraction? So basically mole fraction is the ratio, you can say the ratio between the mole fraction जिसका आप निकाल रहे हो, so the number of moles of that species, that component जिसका आप find कर रहे हो, divided by the number of moles of each and every component. Right, if there are two, suppose यहाँ पे दो components है, यहाँ पे हमारा glucose है and water है. There are two components, component number one glucose and component number two water. ओके सो व्हाट विल बी द मोल फ्रैक्शन. मोल फ्रैक्शन अगर मैं ग्लूकोज का लिखूंगी कंपोनेंट नंबर वन का, सो आई विल राइट द नंबर ऑफ मोल्स ऑफ दैट कंपोनेंट डिवाइडेड बाय ऑल द कंपोनेंट्स, द नंबर ऑफ मोल्स ऑफ बोथ द कंपोनेंट्स. राइट. ओके सो अगर मैं इसका निकालूंगी, सपोज द मोल फ्रैक्शन ऑफ सेकेंड कंपोनेंट, इफ आई हैव टू कैलकुलेट फॉर वाटर, सेकेंड कॉम्पोनेंट 2 में वाटर के लिए लिख रही हूँ, तो आई विल राइट अ नंबर ऑफ मोल्स, एन इज द नंबर ऑफ मोल्स ऑफ सेकेंड कॉम्पोनेंट, जिसका मैं निकालूंगी उसको मैं डिनोमिनेटर में लूंगी, सॉरी न्यूमरेटर में लूंगी, राइट, जिसका मैं मोल
Okay.
फ्रैक्शन फाइंड कर रही हूँ उसका मैं नंबर ऑफ मोल्स मैं न्यूमरेटर में लूंगी, एंड बाकी का मैं जितने भी कंपोनेंट्स हैं लाइक